Добрый день. О, раз тут Михаил Николаевич, а что там с алгоритмом для parity? Что-нибудь?
Я так и не
э,
нашел времени прочитать. Студенты нашли теорему, которая вроде бы как утверждается, ну, утверждение там написано, которое утверждается, но никак не доказывается, написано, что очевидно. И говорят, что им сомнительно. Но я так, посмотрев, там понятно в каких-то местных обозначениях, я посмотрел, вроде как непонятно. Вроде там утверждается какое-то структурное свойство доминионов. Я очень
Ага.
сомневаюсь, что какое-то
Uh,
простое структурное свойство доминионов есть. Hello, Брюно.
Hello.
Но прочитать я так и не смог. У меня тут конец семестра, коллоквиум, как
Ну да.
обычно, контрольная, поэтому пока не собрался. Ну вот, пока чем богаты. Студенты не берутся утверждать, что верно или не верно. Ну, не
Не,
знаю,
ну что никто про это не
надо
пишет
разбираться.
в интернете.
Да, вот как-то никто не пишет. Я подозреваю, что никто не верит, что там написано правда. Можно,
Там
конечно, попробовать
вроде
скормить
человек, так не
какой-нибудь
знаю,
LLM
конечно.
и попробовать попросить найти ошибку. Но я боюсь, это за пределами возможностей ЛЛМ.
Не, ну это вряд ли.
Bruno, we discussed a strange text on archive in which the author claimed that he developed a polynomial algorithm for solving parity games. Uh, the result, if it is true, it is a great result, but people just ignore the text, including us. Но вы не знаете этого человека, да? То есть он действительно какой-то такой непонятно кто.
Нет ни малейшего представления, кто.
Ну вот я так тоже посмотрел, фамилия
Как
незнакомая.
может быть, конечно, человек, типа, раз взял и первым своим, так сказать, первой статье придумал полимерный алгоритм для parity games, но как-то что-то.
С трудом верится, я понимаю.
Yeah, it's a strange situation. Normally, first paper is your result.
Yeah. So we are waiting for Shane. Suppose.
Yes, he is speaker today.
Oh, Peter, your microphone is off.
You're muted.
Yes.
Yeah.
So I just stepped in. What result are you talking about?
Polynomial time algorithm for parity games. But I mean, it's just some paper on archive that claims that.
I don't know what parity games are, so I don't know.
Ah, well,
Is it an NP complete problem?
no, it's not. It's probably
No,
coin P intersection with NP and quasi-polynomial time algorithm is known.
Hmm.
So, but I mean, it's like a big open problem to show a polynomial time algorithm.
Hmm.
So,
it would improve many other results. It would lead to many algorithms, like for approximation algorithm, for vertex cover, and so on. So many people are thinking about it.
Hmm. I come back.
About what?
polynomial time algorithm for parity games.
Ah, yeah. So you invented one.
No. There is a preprint on archive that says somebody claims that they developed a polynomial time algorithm.
Yeah. And
But it
but
seems
you
the
haven't seen
person's
it, that you
first
don't know whether
paper,
it's correct or
so
not.
Uh, No, I mean, it's not some complete schizophrenia, but probably, I don't know. So students of Viale are reading it and they say that there is some theorem that is which said that it's obvious, and to them it's not obvious. So probably, maybe it's not obvious.
Yeah, no, but many theorems which are obvious are not obvious for me, so one should be careful. Okay, let me try to share the blackboard. Select
Okay.
window. Okay, share. So do you see? So it should be something like here, yeah?
Yes, but on the very edge of the screen, it's the borderline.
No, I just
Okay.
try to locate the angles
Yeah,
in corners so you can see whether it's visible.
It's
This
correct.
picture shaded some part of this area, but it's usual thing for Zoom. I can move this picture.
Okay, no, I will try not to come too close to the thing. So the story which I want to tell is quite simple, but has a long history. So there was a paper, a constructive mathematics program by Bishop. He even wrote a book about the constructive analysis when he tried to develop not the Markov style or not the intuitionist style, but somehow to extract constructive meaning from statements. I cannot really understand the program in general, but one specific thing is what he invented is upcrossing inequalities. So there are imagine we have a sequence, bounded sequence xi in summary of real numbers. So we can say that it converges. There is a classical theorem that sequence of some special type converges. But if we understand it, so this means that for every epsilon there exists n, such that for all m1, m2 greater than n, the difference is small. But if we want to prove such a theorem, we find out that classical statement may be true, but it's not constructively true. And the question is, if there is some theorem like ergodic theorem of Birkhoff or some other theorem, what is the classical equivalent statement for convergence, which can be easier prove constructively, which is weaker. And the statement is like this. Imagine we have some interval, alpha, beta. And
I'm sorry, may I ask a question?
Yeah.
What do you mean under constructive?
No, it have different meanings, but actually, if we want to, for example, to provide an algorithm which provides n given epsilon, it may be non-computable.
If a sequence is computable.
Even no, of course, if the sequence is not computable, then we cannot hope much. But imagine the sequence is even computable. But still, it's possible that the convergence is not computable.
Yeah. Convergence may be very slow.
There is a classical example. You take an enumerable but not decidable set, and then you take it in some. Take the enumeration and consider the 2 to the minus ki, the sum of the stages,
I see.
called Specker example. If you know that it's converged constructively in the sense that you can find n given epsilon, then you can decide the set because you know that after some point big terms cannot appear. So you know where to look for them and you can check whether they exist or not. So the idea is that we just watch the sequence somehow, and we look how many times it crosses the gap, which means that it's smaller than alpha, then sometimes bigger than beta, then again smaller than alpha, and again bigger than beta. And actually, of course, the number of going up and down across the gap is the same. So Bishop says about up-crossing inequality, but it's probably even more natural to say about crossing inequality, crossings inequality. So, and there is a very simple classical result for a bounded sequence. Sorry. Sequence is that convergence is equivalent to the fact that all crossings, all these crossing numbers are finite. No, it's in both directions. It's almost obvious. If it's convergence, then of course we cannot go from cross this gap infinitely many times. And if this, for a bounded sequence there is no there are finitely many crossing for every interval. So imagine with sequences between alpha and beta, we divide it into many intervals, and finally it stops crossing every interval. And after such a thing, it's always inside one interval, and then we can repeat this for some smaller intervals. So the idea is, if we want to prove some classical result about convergence, we want to constructivize this, we can try to find an explicit upper bound. So for every, we can say that for every alpha beta, there is some number n, which is a bound for alpha, the number of crossings. And so, of course, now we can try to prove constructively that such an n exists, or give an explicit bound for n, or something like this. And in this way, this will be a kind of less, we claim less, so we can be more constructive. So this is the story. And also Bishop applied these things to ergodic theorem, Birkhoff ergodic theorem. And then Huygens realized that this argument gives the ergodic theorem for Martin-Löf random sequences. So we don't need more randomness than just Martin-Löf randomness to have ergodic theorem true. And here, of course, he referred to some papers of Bishop, and while trying to find this paper, I realized that there are several papers of Bishop's, and there are several versions of this crossing inequality, and there is one especially stronger. Huygens used some of them and reproduced the proof of it, and there is some version which is stronger and at the same time more natural. And the only problem is that Bishop's argument was very confusing. There's a lot of formulas and so on. And then M.Andreev, our colleague, some of you know him, find an easy proof for Bishop's theorem. And finally, when speaking with Wolfgang Merkle, I realized, and Laurent Benvenu and Ivan Titov, I realized that this Bishop's inequality implies almost immediately some kind of Barmpalias Lewis-Pye result, which has very complicated argument, and even the simplification provided by John Miller is also too complicated for me. But still, if you put the things in correct perspective, it becomes obvious from obvious corollary from Andreev's argument for Bishop's theorem, and which can be in its turn become easy due to M.Andreev's argument. So what I am planning to do now, it depends on what you want to say. I can try to start with this Andreev proof of Bishop theorem, and then explain how it's applied to Barmpalias Lewis-Pye, and maybe if you want also how it's applied to Huygens or other results if there is time and there is enthusiasm about this. So this is our plan. And now it's time to say something if you want me to change the plan.
No, I want to see Andreev's proof first.
Yeah, you can. Unfortunately, Misha is not available now because he's just going to Montpellier, in fact, in plane. But still, we can try to reproduce it. So
the full responsibility is on you.
No respectability on my side. You may be responsibility. Respectability is quite different thing.
Respectability, responsibility.
Yeah. That's I cannot hope for. But responsibility I accept. Okay. And let's start with the kind of thing which I think it's easier to understand as a kind of anti-slalom game. This game goes as follows. So there is a sequence of intervals which can be called gates. Like in slalom, you know, the person should to go inside the gate. And in anti-slalom, our goal will be to miss the gate as much as possible. So something like, oops, no, this gate is normal gate. So we start at a given point, and then we want to go, if possible, we want to miss the gates. And the restriction is that our slope, when skiing, you have a maximal kind of angle, so possible slopes are between alpha and beta. So if you're very close to a gate, then you cannot avoid it like this. Or maybe if you just avoid one gate, then you cannot avoid another, and so on. And so
But
let's
this is a piecewise linear curve.
Curve is, you can think about it as a piecewise linear, but if you allow smooth curves, you do not get much better things.
So
it's more
there's
or
a
less the same.
limitation of the
derivative. No, either you can
Okay.
think about piecewise linear curves and the slope of all the segments, or a derivative of a.
How many gates in the game? Finite number.
There is an arbitrary set of gates. We will now
But all of them are parallel.
Yeah, all of them are vertical now.
Vertical and
the
slope
unit
it is possible
is
that there is continuum many gates or not?
No. Finitely many gates.
Finitely many. Okay.
Finitely many gates, but the slopes are arbitrary. And there is some function which is called, let's call it T alpha beta of xy. So this is a point xy, and T alpha beta of xy is minimal number of gates. So we need to cross. No, there are some complications. Whether do we allow touching the gate, but it doesn't matter much. So let's ignore these problems for a while, and you will see that it's not really important for anything. And then we can consider another function, which is a T alpha of x, and which is maximum taken over y of T alpha of xy.
Sasha, I have a question.
Yeah.
So in this setting, the gates are fixed?
Yeah. So when we define the function, gates are fixed, alpha and beta are fixed, and xy is variable. So we have a fixed set of gates and fixed slope. And then we consider how the function t alpha beta of x
Sasha, but
depends
then
on
it
x
is
and
not
y.
clear. It seems that the larger y is, the better. So this is equal to infinity.
No, if y is very big,
Right,
then of course we can avoid all the gates.
right.
So for large y, the function is 0.
Ah, sorry.
We
And we
want to
consider
avoid the gates,
maximum.
not to...
Ah, so we consider the worst y.
Yeah, we consider the worst y. And also, there's also obvious observation. So if we take very large x, we get 0. If we just start when all the gates are finished, we are done. And even if we take very small x of minus infinity, it's also 0. Because if we start far away, then even a small allowed change in slope will allow us to avoid all the gates. So this is some function with integral values and kind of no, you can it's more or less how do it's called, stupinchate. It consists of different something like it can increase, decrease, or do something like this.
Piecewise constant.
Piecewise constant, yeah. Again, there is a troubles when we are on the boundary, but I guess it's easier to ignore this problem. Okay, and then this is Bishop inequality, which is the following one. This integral of t alpha of x is bounded for over all x, is bounded but sum of gate length divided by beta minus alpha. Now, of course, if gates become bigger, then T alpha normally becomes bigger. And if the restrictions are more strict, alpha is very close to beta, then of course we have more restrictions and we need to cross more gates probably. So it's not a surprise that inequality looks like this. We
But
have an upper bound.
is there nothing about the distances of the gates from each other?
No. Let's think why. So let's start with something easy. Imagine that we have one gate. So what does it mean? So if we have slopes, let's draw things with slopes alpha and beta. And if we start from here, then the function is 1. Because we cannot, with the slopes, we cannot avoid hitting, why should it does? No. Delete. Yeah. With the slopes, we cannot avoid hitting the gate. And if we start up on what is? If we start here, we can go in this way. If we start here, we can go in this way. If we start here, we have even a choice. So the function t of xy is 1 here and 0 everywhere. And so the function t of x, which is maximum, is just 1 here and 0 everywhere. And you see that the inequality becomes an equality because this thing is exactly the length divided by beta minus alpha. And of course, if we have some other gate somewhere far away, then we get another zone when we cannot avoid
Sasha, why it's L divided by beta minus alpha? I don't
No,
see.
because you know these things, the upper boundary and lower boundary, they how to say it, diverge with speed beta minus alpha. So to achieve L's distance, so you have two points which move at speeds alpha and beta, and so the question is when they will be on distance L, and that is we divide L by difference.
So the difference in so the area of this triangle, you can express it as the
Area is another story. Area is L squared divided by 2 beta minus alpha, but we don't care about the area because
okay, length. Okay, so the length is the let me try to understand. What is so L2 is the length of the gate, right?
just L, let's make it L1 and L2. It's a length of the gate, yeah.
So the area of the triangle is L1 or L2 or I don't know by times the length of this interval divided by 2.
Yeah.
On the other hand, you can consider
But we don't care about the area. We integrate
yeah,
the
but I
function
want to
of one
express
variable.
the length of the interval that you are. I'm trying to understand the argument why the length is L divided by beta minus alpha.
Imagine we have a point and we have
No, but I mean, I'm trying to do some kind of easy way. Let me try to just.
Okay. Do whatever you want.
So, so on one hand, the area of this triangle is this length times L1 divided by 2.
Sasha, how do you measure angles in radians or
No. It's slope. It's tangents угла наклона.
No, but I still don't understand how. I mean, if you have two gates, then how is it that this thing doesn't depend on how close they are to each other? If they are very close,
it depends. But just
but
the claim is that it's an upper bound.
Oh,
So the
this is an upper
bound is
bound.
universally valid.
Oh, I see.
But let me start what I
On the
started
other-
to say.
So I mean, one hand is that the area of this triangle. I mean, I'm just maybe missing why it's not divided by 2 or something. So the area of
Because
this
it's not
triangle should
area.
be, huh?
It's not area. No, we have 2 points which diverge. One moves with speed alpha and other with speed beta. Bigger speed beta. So the distance of this thing after time t is beta t minus alpha t. And
Yes.
that is equal to
Upward
L.
speed.
Sorry?
The upward projection of the speed Sasha means.
No, the speed of how the distance increases.
Okay. So you're just looking at the distance between the points. Okay.
Ну, у нас 2 точки, они какой скоростью расходятся.
No.
Со
Yeah,
скоростью
I
бета
understand. I
минус
just
альфа.
thought that I should derive this equality from looking at the area of this rectangle.
Yeah.
But maybe it's
not
easier.
needed. It's quite
Yeah,
easy.
I agree.
And now we turn to Peter's question. So the question is how it's possible. Actually, of course, if we have different things, different gates, they start to interfere with each other. And so the function is somehow, if they are far away, we have just two things like this, and everything is okay. But what happens when they start to interfere? So let's consider just some small example. Imagine there is one of them, and there is another one like this. And so this is L1, this is L2. And now we should see, just tell me, let me write down. So here at outside these things we have 0, 0, 0, 0, 0. Because we always can avoid everything. Not completely outside, just, but what is the number here?
2.
2. Good. And what is the number here?
1.
1, and also number here is also 1 because we can go here and avoid it.
Yeah, I mean, I'm imagining that inside these triangles it's 2. I mean, in the intersection is 2, then.
Yeah. So if our picture were correct, we would have something like this. We can have.
So you say the intersection of two intervals, you count it twice, so it's fine.
So the curve will be like this. But in fact, this thing is not correct. I missed some intersections.
Wait. Wait, but probably, okay, wait. So it's like an upper bound, right? So you say, okay, inside this triangle, I cannot avoid.
Now we don't speak about upper bound. I just draw a picture and the
Let me
picture
finish
is
the
incorrect.
sentence. I mean, I'm just trying to understand. So, like, the idea was that we have in the side, we can say that inside one triangle, we cannot avoid one gate. Inside the second triangle, we cannot avoid the second gate.
Yeah.
Right? So you say, okay, then inside the intersection, I cannot avoid both gates.
Both gates.
Hence,
So it should
there,
be 2
the
here.
value is 2.
Yeah.
But maybe, okay, but maybe in some areas where I have, okay, maybe I can avoid one gate, but I cannot avoid the other. Maybe I cannot actually avoid 2.
Yeah. So what is the
I see. So the idea is that when they are when the gates are close to each other, then the area over then the distance over which you integrate is smaller somehow. Right?
Yeah.
That somehow
But let me still ask you, what is wrong with this picture? There are some points when actually the crossing is unavoidable, and I don't draw it.
Yeah. So below the tip of the upper triangle.
Yeah.
So the left tip.
So for example, if we start here, we could avoid separately every triangle, but we cannot avoid both. So actually the correct picture will be more interesting. It will be like this. So here is also 1. And so we get more function is bigger. So it's 1 here, 2 here, and so on.
Okay.
Yeah, and what is funny is somehow in this case the inequality still is an equality, because let's look. So we have this distance. For if we consider gates separately, we have distance, this distance, and this distance.
Yeah.
So they are somehow added on this interval. So the overlap is in this. And it's counted only partially, because we count this value 2 is only here. So this is something which is missing. But this is exactly compensated by this thing, because this interval is the other side of a parallelogram, and they are equal. No, it doesn't matter for our general argument. I just want to get some flavor of what is happening here. So even when two gates cross intersect somehow, they can intersect in a complicated way, keeping the integral the same. But of course, if we have two gates like this, the first is like this, and the second is like this, then we have one here and one here, and so we don't get anything except for one gate, and this gate is lost completely. So this inequality is no more an equality. But generally, it's true. And now the question. Maybe someone already understood this why it's true. So in Bishop's paper there are some kind of formulas. Maybe they're not so frightening, but just me was afraid of. I were afraid of them. But maybe you have some simple counting argument which you will give this bond. And if not, I will explain the argument of Misha Andreev.
So we should know why for 3 triangles there is also no problem.
Yeah, of course. No, we need some general argument which works for any position of gates. It's not so obvious. But if you participate...
So our task is upper bound this T alpha somehow.
Not individual T alpha, but the integral.
But the integral.
Yeah.
But and I mean, one idea is that I can try to count the contribution of every gate somehow separately, but it probably doesn't work because
it's difficult to understand how the contribution combine, because there are some point, as we have seen in our example, when for every gate for a given x we have 0, but if we have 2 gates at the same time, we still have 1. So the contributions are interact in a quite complicated way.
But at least we can, oh wait, but can we obtain some, so yeah, but at least okay, so if 2 intervals for 2 gates intersect, what does it mean?
No, it means that there are some x for which maybe for different y's we are obliged to cross this gate. Not clear how to deal with this. No, of course it's an Olympiad problem, so you should solve it. But actually, it's more a problem about programming Olympiad, not mathematical Olympiad. And the question is, imagine, just for a while, think how to compute this value t of alpha beta of xy. Imagine we know some point. How would you compute this value? Now, theoretically, there are so many paths that it's not clear how to deal with them. So you need to take minimum over an infinite set of paths. Definitely the answer should be computable, but how?
Oh, I mean, I can try to see if I can avoid some set of gates somehow. So, and then compute what's the maximal set of gates that I can avoid. And
so you can try whether you can avoid all gates for a given subset and then take a search over all subsets.
yeah, and I guess
not that it's a large search, so something better is needed.
well, I can, yeah.
How about trying to look at induction, right? You have a certain number of gates, you have this inequality, and now you add another gate on the right and want to see how how it can change this integral. Right.
Yeah, somehow, just the problem is as we had seen with this our example, when we get two gates like this, then it changed an integral in quite complicated way. It increased it somewhere where each gate was not important. So it's not. No, maybe there is some kind of easy combinatorial argument, but the argument of M.Andreev more is a bit different. It's more computational. So if you tried to solve geometric problem in programming Olympiad, or not in programming Olympiad in general, there is a tool which is called moving line. And the idea, we have some kind of points or some configuration, and then we move some straight line, and to see how something changed when we move it. Yeah. And namely, we will consider our function as a function of xy, of y. For given x, we have x, we have some function. No, it takes only integer values and it's piecewise constant. So it sometimes it's bigger, becomes bigger, and then it becomes smaller, then it can become again bigger, and so on. And then the question is, what happens with this function tx with tx when we move our vertical line, and cross some gate. So we somehow add one gate. We cross, somehow move from the, I don't know, x plus 0 to x minus 0, where x is the coordinate of the gate. What will happen with the curve?
Once again, you fix y and you consider this as a function of...
We don't fix y, we fix x. For every x, we have some curve showing how the crossing number depends on y. So this is y, and this is curve tx for some fixed x.
Yeah, and you are asking how...
And then when we slowly decrease x, the curve, of course, somehow changes.
So
by the way, the maximal value of this curve is what we called T alpha beta of x, of just one variable x.
Okay.
So my question is, what happens with this function when we cross the vertical the horizontal coordinate of a gate?
I think it can increase only by one.
Yeah.
Or y's which are along that gate.
Yeah. So what really happens? We just add something, some functions of this form, which corresponds to gate. Because if we are very close to this boundary line, then this gate, we know whether either we don't see this new gate or we see it, and this depends whether we are in the interval or outside the interval. So we get plus something which is length of the gate. So this is what happens when we cross the gate. But also there are intervals between the gate. Imagine we move our x
Yes.
Tx, we have moved from some x to x prime, not crossing any gates. So Tx of some point x, Tx of y, sorry. So Tx of y prime. We want to express it in terms of Tx of y. So imagine we know this function for some value of x, and now we want to find its value with smaller x prime.
Well, I guess the best you can try to do is to try.
So if we are here, then we have some choice. We can go with any slope before the next gate.
Yeah, but then the value can be different.
Yeah, so we should go with the slope, which makes the number of crossing minimal.
Sasha,
So
I think we should start with an easy observation that the function can only decrease, right?
Not if alpha and beta are of the same, if like this, then it will not decrease, because we are forced to go at some place when we can have some value of. So we can avoid things starting from here, but if we start from here, we are forced to move somewhere, and then we are forced to cross the.
I see. So it can increase also.
Yeah, but what is the answer? We need to find the minimal value. We need to move optimally. We need to take all the possible position. X minus. So this is an easy, just kind of dynamic programming things. We choose the optimal way to behave on this. We don't cross anything when we move from x to x prime, from x prime to x, but we want to get what minimal number possible after we get somewhere.
Sasha, y prime should be on the right, I guess. Tx of y prime.
Y prime, of course. Yeah. And what we should understand, what it turns, but indeed, Holly, you are right. It doesn't matter, but let's imagine that alpha is smaller than 0 and beta is greater than 0. Then what happens if our function Tx was like this? Then of course it will become smaller and smaller. And because the boundaries will come to each other. And so this peak size of this peak decreases with speed beta minus alpha. So if alpha is equal to beta, so it's not at just more or less fixed speed, then the peak just moves. But if alpha is smaller than beta, then we have some freedom. And this freedom helps us to decrease the size of the peak. Because at every point, in every point here, we can just move. If we want to avoid things, we can go either with speed beta or with speed alpha.
No, but I don't understand what you're trying to. So what statement you are proving now? I understood that how in potentially we can compute these things one after another, adding gates,
Yeah,
then they
I
will
just
like
consider
pick
some
linear
simple
functions, and
example.
we compute it according to that formula somehow.
I consider a simple example. Imagine we had one
No,
for
but it's
some
an
x
example of what?
of the change of the function. Imagine that for
But we are already trying to understand how it would lead to this inequality, right? Or we are just trying to
no,
understand
not
compute.
immediately. We will start with simple example and then consider more complicated thing. So simple example is that we just our tx is just one peak, and then I say that tx prime will also have one peak, but this peak will be not so wide. It will decrease.
Because you can avoid this peak
Because we
by
have some
the
variability in speed, so we can have there are some things to avoid. We can avoid sometimes things. No, actually, it corresponds to the picture. So we have the zone alpha beta in our example, and this was 1, and there was 0. And so, of course, if we take move our line to the left, then the peaks become smaller and smaller.
By the way, so the maximum is decreasing. That's true, right?
No, also the maximum is decreasing.
At least this is true.
At least this is true. But what I'm saying that the peaks becomes more less wide. Уже они становятся.
They become less wide.
And even we
The
know.
peaks are maximum peaks.
No. If we have any curve, actually, the general claim is like this. For example, we have a curve like this. Then the left bounds are moving with speed. If they are of opposite sign, they move to each other, and all peaks become smaller.
That's some kind of informal statement. We want to say that the integral is decreasing or what in the end?
In the end, we want to say that the integral is decreasing, and the speed with which the integral is decreasing is just the maximal height of peak, t of x, times beta minus alpha.
But okay, I forgot. So this is tx, the function tx. We are interested in the integral over all x's.
Yeah, over all x's of this function.
Of this thing.
No. Finally, we are interested in the maximum. But
okay.
Now we look how fast the integral decreases.
The integral of tx.
Integral of function tx, this area, or this area.
So it decreases.
It decreases.
And moreover, you say that it decreases.
It decreases because all peaks are become thinner. So in this picture, for these examples, it decreases 3 times beta minus alpha, because there are this peak, and this peak.
So what is the proof that it decreases?
Because the boundaries, left and right boundaries of each peak go in the.
What is a peak? What's the definition of a peak?
No, it's like in expressions with brackets. We increase and we decrease. We have a corresponding decrease.
But maybe there is some kind of formal argument that so far I don't know. Is there possible to explain it somehow? I mean, there's some clear statement that the integral decreases, but then
Yeah.
there are some peaks that are.
No, I don't see any formal argument which different from a formal one. The informal one is that we have some places when the function increases, and each place is matched with the corresponding decrease function. This is matched with this. This is matched with this, and this is matched with this. And if there were something like this, or I don't know, they will be matched with each other.
What function do you mean? T superscript x, T subscript alpha beta?
No. T super.
There are too many functions in the play.
Okay, so for T superscript x is just the vertical section of function T.
Yes.
As function of two variables. And also its maximum is function T alpha T of one variable. And the graph is the graph of T superscript x. Okay, maybe the notation is confusing, but just we look on this function of two variables. We have only one function of two variables, and we look at its vertical section, and look on the integral of this function over every vertical section.
Sasha, can I make a very simple observation? Imagine that beta is equal to alpha. Then you can move only with some on a straight line. Then the integrals are equal, right? Is it true or
true?
Okay.
Then everything will just move with speed beta.
Yeah, okay. And then you say, if you allow me more freedom, then it can decrease. Because maybe I try to avoid
for the left boundary, you have more freedom and speed than from the right boundary. So you move with different speeds and the size decreases.
Okay, so I mean, yeah, so if beta is equal to alpha, then basically the value of the function correspond, I mean, if I want to compute it at the point, I mean, this is like a translation, right? The functions are obtained.
The graph will just move.
I don't know, like depending how much distance I'm doing.
It will just move with speed alpha or beta.
With speed alpha. Okay, so I guess I understand that it can only decrease if I'm moving. And then you are making some statement that it will decrease at least by something or something like that?
Yeah,
or
the statement is that each peak, this one, and this one, and this one, and this one, and this one, will provide a decrease with speed beta minus alpha, because height is 1 of every peak, and its sides move to each other. The distance, horizontal size of the peak, decreases with speed beta minus alpha.
So we consider just intervals where the value of this function is maximal.
Not only these two intervals. Here the value is maximum, but we consider also the other peaks. What I wanted to say.
At this time, we do not consider the maximal y. We consider that as a function of y.
As a function of y, yeah.
So, and Sasha keeps asking about another function, which is only a function of x, maximal y.
Yeah. No. We want to show that the speed of decrease in the integral of this function, of this line function on the vertical line, its integral decreases, and the speed of this decrease is at least the maximum times beta minus alpha.
Sasha, this is not that integral we are interested in. This is another integral. This is another
Yeah,
integral.
I understand. It's the integral of the function tx.
Yeah.
But at least I would like to understand the statement. So the speed of the decreasing of this integral is at least something.
At least something, namely, at least the maximum times beta minus alpha.
Okay, and it's consistent if beta is equal to alpha, then this is just zero and the integral doesn't change.
Yeah.
Okay.
And indeed, if we have something like this, if we just have only one peak of each height, it will be inequality, because each of these areas, horizontal areas, will decrease with speed beta minus alpha. And the number of these rectangles is T alpha of x.
Let me try to understand. So the speed of decreasing is it? So let's say if I make step in x, so I'm making steps in x, so I'm moving x.
Yeah, by some small or not so small value delta x.
By delta x. I don't know, by one. So we want to say that the change in the integral will be at least beta minus alpha times the maximum value.
No, assuming that for this entire change, for all the values of x while it changes, the value of t of x is the same. No, so normally in this picture it will decrease with speed 3 times beta minus alpha up to a point when this upper peak disappears. And
yeah,
then t becomes smaller,
but
and
at least so you are assuming that the value of t alpha is the same in the whole interval.
Yeah.
Okay.
No, again, the speed can change. For example, if we have a very thin peak here, then at first it will make an influence. It will also decrease with the speed. But then it becomes zero and decreasing stops.
So let me try to make another simplifying. Maybe it's not very simplifying, but at least I think so. It's not important. Just the difference between beta and alpha is important because I can translate everything by their difference. So we can think that there are just maybe some opposite numbers.
Yeah, minus 0.1 and plus 0.1. Then all the boundaries go to try to meet each other with this fixed speed.
Okay, so I can choose to move just as a straight line and I will end up in the same value. So this probably will not decrease the integral, but at some points in some y's, right, I can move by 0.1 or 0 minus 1 and take a smaller value.
Yeah, so you can somehow, if you start somewhere here, where is this? If you start somewhere here, you have some choice. You can go in some, there you have some freedom, and this freedom leads to the fact that the peak becomes thinner.
Yeah, but why so I mean, okay, so if I have this peak where I have the maximal value, for example, just the very maximal value.
Yeah.
So you say that in 0.1, I don't know, so how exactly? So like
I just say that the things on the borders on the right will move left with speed 0.1, and the left borders of the peaks will move right with the speed 0.1.
А,
Сейчас я чувствую недовольна, но я не понимаю, чем. Что-то вам не нравится здесь. Но спросите что-нибудь. Ask something.
Но я
ну,
недоволен тем, что я не понимаю общего плана, честно говоря. Мы доказываем, что интеграл ограничен чем-то.
So
При этом
why,
ты хочешь
why do you care about that area? That's the question, I guess.
Just this will finish. This is the last step. Imagine we move the line from plus infinity to minus infinity. We move x from plus infinity to minus infinity. And we watch on the integral of over y this function tx.
yeah.
And then we know that some things happen. What happens with this when we move? Sometimes it increases. When it increases, it increases by gate length, just by gate length, because we add just one new we add just one the interval which corresponds to gate.
Yeah.
And then, while moving between things, it decreases with speed tx, with speed t alpha beta of x times beta minus alpha.
Yes.
At decrease cannot be bigger than increase. Increase just the sum of the number
and end with 0, right?
We start with 0, we end with 0, and so the total increase in the integral is just compensated by the total decrease. And we have some guaranteed speed of decrease, which is proportional to tx, t alpha beta of x. And so the integral over t alpha beta, integral over x of this integral, so we can write beta minus alpha. So this is total increase, total decrease, and this is total increase.
The general idea is clear now, but your arguments about peaks, which are
hand-waving about peak, you don't like.
Informally, it looks very plausible, but to be sure, I should write down some formulas.
Yeah, maybe you will get exactly what was written in Bishop, because there are some formulas which I can't follow, but still I guess that at least the idea should be clear.
But, Bishop used the same idea.
Not clear.
You have a very clear idea, and you should just justify it. And I understand why you draw all these pictures, but I'm not sure that you did not miss something.
Okay, so you say, yeah. So I'm trying to understand the statement about the speed.
Yeah.
So you're changing x by a very small delta x. Means that in the function you can move by delta x times beta minus alpha and
This
take
is
the
freedom.
value. No, y like it's yeah. So I can move y by delta x times beta minus alpha. And you say that I can decrease the whole integral by delta x times beta minus alpha times this maximum value.
Height. Because you actually decrease with the speed, which is the sum of all the numbers of these rectangles. So in this thing it will be 4. 1, 2, 3, and 4. But at least the number of the number of peaks is at least the height.
Sasha, I don't understand why your arguments are so additive. You provided an example when there is some region in the plane when we can avoid any gate, but we cannot avoid both of them.
Yeah.
And in your current considerations, it seems impossible because you just sum up all shadows of the gates.
No, it's not so. It's not.
So you're saying, okay, somehow you're saying that, okay, let's say the maximum value, I don't know, is 100, right? Let's say.
Yeah.
You allow me to change. So, okay, then you say, okay, there is a region when the value is 100. There is a region when the value is 99.
Yeah.
Well, you want to say, okay, so one statement that all intermediate values, okay, right? In some kind of general position, you must have all intermediate values with positive.
Yeah, it's not a problem if we have two values like this. If we have a peak of size 2, it's just both the width decreases by speed beta minus alpha, so the area decreases with speed 2 beta minus alpha.
Yeah. Okay, so we can. So you say, okay, so there is some strictly positive area where the value is 100, where the value is 99, and so on.
Yeah.
Up to 1. So for each of this area, so you have an area where the value is 100. You know that if you can
the domain when the value is at least 100, at least one.
At least 100.
Yeah. Let's consider.
But okay, let me say somehow. Okay, first approximation of the argument.
Yeah.
That if there is, so you want to say, okay, there is some integral of the area when this is 100. So this is 100 times this area. And you want to say that, okay, the very the border parts, the parts of this area that are you can go how to say, you can leave this area by moving a little bit by delta x times beta minus alpha.
Yeah.
You want to say, okay, now this means that in this area, the new function will decrease at least by this. At least there will be at least one peak, and you want to say, okay, at least this will be some interval, and at least this endpoints will close to the ends of this interval. We will be able to leave this interval, and so the whole integral in this part will decrease at least by beta minus alpha times delta x by the distance that we can.
I think I can say more formally as you want. So we want to study the integral of this tx function, but this integral is sum of the measures of the over c, the measure c. Natural C, the measure of zones when this function is greater than C.
Actually, yes.
And each zone.
So because
decreases.
You want to say, sorry, because this is 1 plus, so the area where it's 2 is counted twice, when it's 3 is counted
exactly.
times, and so on. And you want to say, then it's clear.
And each of the sets, it's a union of interval.
Yes.
And our formula, our dynamic programming formula, just exactly means that each interval decreases the sides of the interval meet each other.
Yeah, but only one small way.
Yeah.
Yes, because you wrote it that way. So if it's a union of intervals where, I don't know, the value is at least 50, right? So if
Yeah.
you're leaving these intervals, the value is already 49. Yeah, okay. In the ends of these intervals, I mean, actually, it's better for us in terms of the speed of the decreasing of the integral.
Yeah,
They have,
when we have more intervals, the speed is bigger.
but we have at least one interval because it's non-empty.
Yeah,
so
because of course, there are some. All the sets are non-empty if up to
So
maximum
I guess this is
value.
even like 2 times this, right? I mean, or can we say this?
No. If the interval is between minus 0.1 and 1.1, it's 2 times 0.1. But beta minus alpha is 0.2. So there is no additional factor 2.
Yeah, okay.
Концидвигаются скоростью альфа и бета, а
Yeah.
сближаются скоростью бета минус альфа. Окей.
See, now it's like, yeah, I mean, now it's okay. Now it seems somewhat formal argument.
For somehow formal argument.
Somehow understandable.
Okay, so no, if you agree with this, then I can move to the other to the application. But we need to this Barmpalias Lewis-Pye thing. But if this is the main technical thing which is invented by M.Andreev. So, and I found it very nice, and I don't see any. I can send, if you wish, I can send the paper of Bishop. Maybe more clever people will understand what is there.
Sasha, and once again, this can be used to prove ergodic theorem for Martin-Löf and also to prove Barmpalias.
Yeah, and of course it can be also used to prove classical ergodic theorem, which is just weaker.
I see.
But I want this technical part to be clear before going anywhere else.
I think it's clear.
It's
a very
clear.
Nice argument, by the way.
Yeah, that's all the praise should go to Misha, who is on the plane now. Okay, why cannot I?
But maybe we can, I don't know. It's a very good argument, but it took a lot of effort to understand it. So I don't know, maybe we can think of continuing the application next time when we will have like...
No, if you just let me say what weaker statement we will need for the application.
Okay.
And then the application itself can happen next time. But then I should... How can I... No. I want to say control. How do you erase things? No, I cannot erase things. Oh, it does something. No. Unlock all. Okay, and there is nothing to... Oh. How do... People can erase somehow things, but...
What application are you using?
It's Miro board. It's almost good, but the only thing which I cannot learn is how to erase things. Sometimes it happens, sometimes not, and I didn't understand what was the reason. And what I wanted to how we will apply it. We will apply it not to the set of intervals, but we'll apply it to some curves. And if we have a curve, we also can consider it, and we have some point x, y, and some alpha beta interval, we can just count the number of up and down crossing of this thing. So here we have one up crossing because slope was below I alpha and it becomes bigger than beta. One up. Here we have one down. Here this is not an up crossing because we don't reach the big things, but this is the second up crossing. Second up crossing and no down crossing after. And then number, we again consider this thing as a function of x and y. And again consider T alpha of x as a maximum over y, T alpha beta of x, T alpha beta of x, y. And the claim is that the integral over x, T alpha beta of x.
Sasha, wait a second. Do you again consider anti-slalom game?
No, anti-slalom game, but now we want to make as many. No, we will consider it, but now we just look. Somehow the person is moving along a curve now. Somehow, let's go in another direction. Imagine the point is moving along the curve with not the point is there is any curve, but if we have this alpha beta angle, then we want to just count the number of crossings. Forget about slalom game. It's bad idea. Just if we have a curve and we have a angle, we just look how many times the curve goes from below to above and vice versa.
The minimal number of what?
Not the minimal number, just the number of number of crossing. No,
Sasha, what is xy? It's the origin of the angle.
No. We have a curve, a graph of a function.
Okay.
I don't know, f
Yeah.
y is equal to f of x for x between a and b. Just any continuous curve. And then we start with some point xy, arbitrary, and take kind of angle of observation between slope alpha and slope beta.
So xy is the origin of that angle, right?
Yeah, this is xy.
This is xy.
Yeah.
Okay.
And we see how many times the curve goes. So now there is no kind of optimization. It is just we count how many times it goes from one side to another side.
From
And of course,
one side to another side of what? You have two lines.
Of this angle. For here the curve.
So
is
how
below.
many times it goes to the angle and goes out?
No. For example, this thing we don't count as crossing because it doesn't reach the upper angle. So
we count when we enter the angle and go out on the different side.
Yeah. We want to cross the angle. So if we just go a bit inside the angle and go back, it doesn't count.
I see.
When we cross from one side to another side. No,
and
formally, we should consider the maximal number of maximal length of a sequence x0, x1, x2, which are alternatively above the angle and below the angle. Maximal length of k such that there exists a sequence x0, x1, xk, which go up and below. Why it's important? because somehow it corresponds to our idea that we have some moving point, and we look how many times it crosses, goes from left to right of some gap alpha beta, and from right to left. So here we just consider the direction when we see a point on the curve. How many times it's oscillates. And now the claim is that integral of this function t alpha beta of x dx is bounded by times beta minus alpha. Okay, no, better not to do this way. Okay. This is bounded by big O of b minus a plus variation of function f divided by beta minus alpha. This in O we have some very specific constant like 2 or 3 or whatever. It's not.
I'm sorry for a stupid question, but what is variation?
Variation is what is published in the tourist guide. You say that during the walk you go up to 300 meters and you go 700 meters, down 700 meters, and the sum of this up and down things is variation. So here the variation is the length of this thing plus the length of this thing plus the length of this things and plus the length of
Is it a standard thing?
Yeah, it's bounded variation functions are just functions which are differences of two monotone functions. Okay, if f is good enough, the variation of f is the integral of modulo of f of prime of x dx.
So it is defined in this way for smooth functions.
No, for smooth function, or if it's just a polygon.
For arbitrary continuous function, it cannot be defined in this way.
No, actually, it cannot be defined for every continuous function. You take just the maximum over all splittings of the a is x0, xk equals to b, sum of f of xy minus f of x minus 1.
Okay, I forget words. I thought that variation means something different. Okay.
No,
now I understand it.
No, in English. In Russian, it's функция ограниченной вариации, standard name. But in English,
I understand. I understand. In Russian, it is the same, but it is some misunderstanding in my mind, so I'm sorry.
Okay. Anyway, we will use it only for very small. Just it's total increase plus total decrease. Yeah. And the idea why it's true is very simple. So imagine we have we have some broken line here. Now we can assume that the curve is broken line and it will always be the broken line in our examples. Then we can replace each then of course the intersection with the if we have we have this, each segment of the curve is a gate which we want to avoid crossing, then of course every crossing of the curve means that we will intersect one of these segments. So if the curve goes from below to above, then every line moving with speed between alpha and beta, we will definitely intersect it somewhere. Мы не можем, если мы кривая с одной стороны переходит на другую, значит, одно из звеньев мы должны будем пересечь. So this new crossing number is bigger than our crossing number. For skewed gates. And then we need to replace every skewed gate by some vertical gate. And this is more or less easy. If we intersect this gate, then we will intersect this gate somewhere. Here are slopes alpha and beta. We will intersect this gate here. And the length of this new gate will be big O of the change in F plus the constant will now depend on alpha and beta. We can change in F and change in X. Just okay. I see that I'm confused, everyone, with all this. I just wanted to say that what we are actually interested in ergodic theorem and in Barmpalias and Lewis-Pye arguments are the crossings over curves. And our lemma about slalom was just a tool to obtain this curve crossing things.
Okay, but this last remark was not clear. I didn't get it actually. I mean, I got that M.Andreev argument, but not
this one. Okay. Okay. So I have a request for Misha and for Sasha. I will send you Bishop paper, and please take 5 minutes to look at it. And if maybe you will understand something and explain.
Are you sure that he used the same idea?
No. Bishop exactly has the lemma of slalom. And just the proof is not clear.
The proof, M.Andreev came up with this proof trying to reinterpreting what's written in Bishop.
No,
or
he was lazy and he didn't look at Bishop. I was asking him to take a look, but he...
So then the request is what? To see if this is something really similar or is some other different argument?
No, say whether you can understand anything in Bishop after 5 minutes, and if yes, what is there?
Well, okay, that's I can...
No, you can say that you don't understand in 5 minutes.
I can answer in advance. In 5 minutes, I don't understand anything.
Okay, 6.
Okay. No. We can
6 hours of free time.
I don't dare to ask you to do this for 6 hours.
No. In 5 minutes, I don't understand anything.
But then, okay, maybe next time you can restate the anti-slalom lemma when we have seen already the proof. Without the proof, then repeat this thing and then repeat application.
Then go to applications. Okay.
Then go to applications.
Okay.
So next time.
But I think that this Misha's argument is very nice, and I wanted to explain it in full details. So
but then there was some kind of other argument directly when you applied some kind of combinatorial algorithm, this kind of stuff, when you apply it to Martin Löw.
No. We just apply this claim, this one, we can apply it both to Martin Löf and to Bishop, to Barmpalias and Lewis-Pye.
No, but then there was some kind of argument before with some potential function or something.
Yeah. It was. I would say it. I can explain the difference. There was an argument which was in other paper of Bishop and which was also in Huygens paper. And the Huygens paper, he studied the number of upcrossings if we start our angle from a curve point. So it observes the curve only from the points which are on the curve. And we estimate the integral of these things. And the other Bishop's paper and Andreev's argument is better because instead of just taking a point on the curve, we are allowed to take maximum over all y. And this is important for Barmpalias. The original argument was not enough for Barmpalias. So only when I learned that there is a stronger upcrossing inequality, then I realized that it gives immediately what we want about Barmpalias. So there is some importance in this change.
Okay, so next time we will.
Yeah, so I apologize for being unclear, but I hope that at least some idea.
No, but I mean, in the end, we got some decent argument.
Yeah. As Ширяев told to Успенский after his talk once, мы были готовы к гораздо худшему. I like this review very much.
Okay.
Yeah, okay. So thanks a lot, and I thank you for listening. And Bruno, maybe you will come with another proof next time. But let's see.
Yeah, I tried the potential, but I couldn't find it.
Okay.
For anti-slalom game.
Okay. You have 5 minutes more after the talk, and then you will find some.
Okay, bye.
Okay, bye.
Thank you. Bye.
Bye.
Thank you.